In this section, let's take a look at the graphs of other trig functions. We've already analyzed our sine and cosine, so now let's analyze the other graphs. And so the graph of the tangent function, let's remember a couple of things about tangent. First of all, tangent of x, forgot a letter there, tangent of x is actually equal to, based off your sine and cosines. So let's say tangent of theta, that's much better, is sine theta over cosine theta. And so when we consider how do we find these values, let's look at theta and f of theta. And let's just space it back to our unit circle again, good old unit circle, sine over cosine. So I want to look at negative pi over 2. At negative pi over 2, that has a sine of -1, a cosine of 0, so it's undefined here. At negative pi over 4, this is negative square root of 2 over square root of 2 over 2. So when you divide something by itself, it just has a difference of negative. At 0, we're at 0 over 1, so just 0. At positive pi over 4, again, square root of 2 over 2 divided by square root of 2 over 2, so this would be equal to 1. And then at pi over 2, that's 1 over 0, so that would be undefined. And so let's take a look at what this is as we graph it. And so we are going to space it out by pi halves again, or pi over 4, each tick mark. And this is going to be your 1, and this is going to be your -1. And so at 0, we're at 0. And then when we move over to our pi over 4, that was at +1. At pi over 2, it's undefined, so this is actually a vertical asymptote. At negative pi over 4, that's -1. And at negative pi over 2, that's undefined. And so this creates a curve that looks something like this, almost like some cubic curves. And we say that this has a period of pi because you can see from here to here, that's a unit of pi. So this one has a period of pi, so not 2 pi like the previous ones. Now it does repeat every pi, so if I move over, I could graph some additional points. And it has a bunch of vertical asymptotes if we continue graphing. And so more continuations of this graph look something like this. And so some observations. We can see that the domain is whatever theta is cannot equal pi over 2 because that's where those asymptotes occur, but it happens every pi period. So we actually say plus k pi, so we can move over where k is an integer. And remember, your integers are like -1, -2, +1, +2. And so that's going to create a vertical asymptote every pi units. So the range of this function is actually -infinity to infinity because you can see we have arrows going upward forever and downward forever, excuse me. And so this is also an odd function. F of -x is equal to -f of x. And we can kind of see what's going on with that tangent. So kind of interesting there. We got a different shape than just with our sines and cosines. Let's move on to another trig function. Let's look at the graph of our secant function. Now remember, your secant function is equal to 1 over cosine of theta. And let me switch colors so we can know we're working on this next one. So this is equal to 1 over cosine theta. So again, I'm going to look at some thetas and f of thetas. I'm just going to use my trig circle. So I'm going to say, what is it at negative pi over 2? It's actually undefined. At negative pi over 4, that would be 2 over square root of 2. I'm just flipping all my cosines on my unit circle. 0 is at 1. Pi over 4 is at 2 square roots of 2. Pi over 2 is undefined. 3 pi over 4 is -2 over the square root of 2. Pi is at -1. and 5 pi over 4 is at negative 2 square roots of 2. So when I go in to graph this, at negative pi over 2 we're undefined, and at pi over 2 we're undefined. So I'm going to go ahead and draw those asymptotes, just like what we did on our tangent. So that's going to occur every pi like we just saw in tangent. So there's all your asymptotes. Then let's create our curve. We know that at 0 it's at positive 1, and so let's just go up by 1 units on these. We know that at pi it's at negative 1, so we're seeing a trend here. Excuse me, I told you I was going to do it by units of 1, then I did units of 2. And then it's going to move back up on your 2 pi's. Now, what else is happening? Well, what you can see is that if I were to graph my cosine function, I actually get a graph that looks something like this. And so what the secant function does is it is reciprocating that, and so it looks actually like this. And it's just going to have vertical asymptotes because we get that division by 0. But I like to graph the cosine function in there and relate it to something that you already feel familiar with, and then you can see what's happening there. Now the period on this is actually going to be this length so that we get an upward curve and we get a downward curve. And so let's write some of the things that we get from this. We get that the period of 2 pi, the domain is theta cannot equal, we don't want those asymptotes, so pi over 2, again, plus k pi. And then the range is negative infinity to negative 1 and 1 to infinity, because we don't want that in between part where the cosine used to be. And again, this is also an even function like we've seen in other ones. So we now have sine, cosine, tangent, secant. Let's do cosecant. Now with cosecant, we can create a table, we can look at them, but I want to show you how to create it just like what we did with that previous one. And so cosecant is 1 over sine. And so if you consider your sine curve and you're doing the opposites of those, then we can see what's going on with this. So let's do it like we did the previous one. Let's graph that sine curve and then let's reciprocate that. So here's your sine curve. Create some asymptotes every time it crosses 0. Create reciprocal curves based off your sine curve, just like what we did in secant. And so really pretty interesting there on how those two can be created pretty easily. Now you can go in there and you can do our table on the left like we've been doing, but I thought I would kind of speed through that process. So the period for this is going to be equal to 2 pi. The domain is theta cannot equal 0 plus k pi, where k is any integer. Your range is equal to negative infinity to negative 1, union with 1 to infinity. And this one is an odd function. So f of negative x is going to be equal to negative f of x. So pretty interesting to what's happening there. Now I'm going to do the same kind of thing as we go through our graph of our cotangent. Because remember, your cotangent is equal to 1 over tangent. And so what we're going to do is, looking at this one, it just reciprocates it. So I'm going to draw it pretty quickly for you here. It has asymptotes at, has asymptotes at 0, pi, 2 pi, etc. And then it just kind of works with that curve a little bit differently, and it looks something like this. And so you can see it's real similar to what it did with tangent, but just reciprocate it. The period of this one is equal to pi, like it was for tangent. The domain, theta, cannot equal k pi. Your range is negative infinity to infinity. And this is an odd function, so f of negative x is equal to negative f of x. But again, we can follow the same conversations like we were doing with our other functions, do our table of values, reciprocating all of our tangents, but this is the curve you're going to get. So I hope this helps with just trying to figure out what do these different trig functions look like.